So as you can see by looking at this slide, we're jumping ahead now to lesson 9. There's something in lesson 9 that the high school would like you to have before you head over, and that's just an introduction to the quadratic formula. So today's lesson is going to cover 3 targets. 1, what is the quadratic formula? 2, how can I use the quadratic formula? And then 3, where did the quadratic formula come from? All right, so first question. What is the quadratic formula? So the quadratic formula is a formula that provides the solutions to a quadratic equation. All right, so we've actually already been doing that. We did it by factoring. We did it by completing the square. This is yet another method, and there are times when using the quadratic formula is preferable to either completing the square or factoring. We already know there are times we can't factor, and then completing the square, that can be a little bit cumbersome when trying to figure out the x-intercept. So this is a way that it looks a little clunky, but once you start getting used to this, it becomes a way to figure out the x-intercepts, or what we're going to learn today is also called the roots of the equation by using the quadratic formula. Okay, so the quadratic formula is based on the variables used in the standard form for a quadratic equation, which is a x squared plus bx plus c equals 0. We're setting it equal to 0 because remember, when y is equal to 0, that's when we get the x-intercepts, or what we call the roots. And that's the whole point, is to figure out x when y equals 0. That's what the quadratic formula does. So it's a quicker way to find the x-intercepts, or the roots of the equation. All right, so here's the formula. Listen while I read it. So it would be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so one thing people often remember about their algebra classes is the quadratic formula. So I bet if you said something to your parents like, hey, today we talked about the quadratic formula, x equals negative b plus or minus the square root of b squared, blah, blah, blah. Some of them will probably remember that. Okay, so the next question is, how can I use the quadratic formula? All right, so you can see I've done a little workout on paper here, so I'm going to try to talk us through this. So I wanted us to start with this equation first. So y equals x squared plus 4x minus 21, and we're going to assume it equals 0, right? So that's what we're really solving for here. In this case, a is equal to 1. So remember, we looked at the standard form. So it's ax squared plus bx plus c. So the a is equal to 1. Remember, if there's no variable there, no constant there, we can assume it's 1. B is equal to 4, and c is equal to negative 21. All right, well, here's how you use the quadratic formula. You just plug each of these things into its appropriate place in the formula and then solve. Okay, so I have x equals negative b, so since b is 4, it's negative 4, plus or minus the square root of b squared, so b squared, minus 4 times a times c, all over 2 times a. So basically all I did here was plug everything in. All right, now I'm actually starting to solve. So then I have when x is 0, when y is 0, x is going to equal negative 4 plus or minus the square root of 16 plus 84. So when I multiply that out, that's positive 84, all divided by 2. All right, well, nice thing, this ends up being 100, so that's sweet. All right, so then I've got negative 4 plus or minus the square root of 100, all divided by 2. So then, again, simplifying it further, now I'm separating my plus and my minus. So you can see that all of these are going to have 2 answers, and I think that makes sense if you think about the fact that most of the time a quadratic equation has 2 x-intercepts, or what we would call 2 roots. All right, so then I did negative 4 plus 10 over 2, which is 6 divided by 2, that's 3. And then I had negative 4 minus 10 over 2, which is negative 14 over 2, which is negative 7. All right, so basically all I did was plug everything in here and solve it. All right, so for this one, I thought, let's just factor this one. This is one that we could easily put in factored form. This time I remembered the equals 0. I used the chart method here. All right, so factors of the first, factors of the third, I'm looking for a difference of 4, a positive 4. So that's my 7 and 3. So I want a positive 7 and a negative 3. I made x and negative 3 my outers, and then x and positive 7 my inners. And then if I set each of these equal to 0, you can see x is negative 7 or 3, which is what we got on the previous page. I also went to Desmos and factored this. I put it in like this. And as you can see, my x-intercepts or roots are negative 7, 0, and 3, 0. All right, so that worked. All right, so the reason I did this first one with you that we could actually factor is to prove to you that, yes, the quadratic formula does work. All right, we'll talk about where it came from at the end of the slideshow. All right, so now I'd like to try another one that will actually not factor well. Now, in a case like this, we always could do completing the square. That's an option, all right? It's just that the quadratic formula is a better option for finding the roots, okay? So that's why we learn it. All right, so I did remember the equals 0 this time. This time A is negative 3, B is 12, and C is 1. So again, I plugged everything in over here. So negative B, negative 12, plus or minus the square root. So I just squared it right away this time. 144 minus 4 times A times C, so negative 3 times 1 over 2A, that's negative 6, because it's 2 times negative 3. All right, so I've got negative 12 plus or minus the square root of 144 plus 12, all divided by negative 6. So I've got negative 12 plus or minus the square root of 156 over negative 6. So what I did is I just found the estimate for the square root of 156. As you get into Algebra 2, you're going to learn ways to simplify square roots a little bit better so you can have exact answers. But for now, I just rounded this. So we have negative 12 plus 12.49. That's the approximate value of the square root of 156. So that all divided by negative 6. And oops, my 9 got cut off here. Negative 12 minus 12.49 all over negative 6. All right, so for this one, I ended up with 0.49 divided by negative 6. For this one, I ended up with negative 24.49 divided by negative 6. So then you can see what I got for my values. Again, these are rounded. Often in mathematics, we do round to the nearest thousandth. In this case, rounding to the nearest thousandth actually did give me 0.49. All right, so those are my roots. Let's see what happened. Okay, so my roots, again, I want you to get used to that term. It's the same as x-intercepts. Let's see if we got the same thing. Sure enough, I put it in the graphing calculator like this, and I have one root of negative 0.082 and another root of 4.082. All right, so that worked out well. All right, last one. Okay, this one comes up with something even more fascinating. All right, so watch what happens when we put this in here. So I have that A is equal to 3, B is equal to 6, C is equal to 10. When I plug everything in here, so this is negative B plus or minus the square root of B squared minus 4AC all over 2 times A. So when I simplified this, this is 36, and then this is negative 120, so minus 120 over 6. Then I end up with x equals negative 6 plus or minus the square root of negative 84 over 6. And then you can see I have written here, oops, problem. All right, here's the problem right here. Trying to find the square root of a negative. Okay, so think about this for a second. If we were trying to figure out the square root of 25, that is, what times itself gives you positive 25? Well, we have two options there. Either positive 5, because 5 times 5 is 25, or negative 5, because negative 5 times negative 5 is also positive 25. So a positive times a positive is a positive, and a negative times a negative is also a positive. Here's the problem when you're trying to find the square root of negative 25. You can't do it. It's not positive 5, because positive 5 times positive 5 is positive 25, and it can't be negative 5. And if you're saying, well, it's -5 and +5, well, those are two very different numbers. So a negative actually cannot have a square root. Well, in algebra, we have a letter that we basically just determined as I, and it stands for an irrational, it stands for an imaginary number. It's an imaginary number because it's not real. It doesn't actually exist. So I, which stands for imaginary number, is equal to the square root of -1. Right? What we're really getting into with this is something called theoretical mathematics. It is something that you will delve into in Algebra 2 and in your future math classes, and it is needed sometimes, particularly in certain branches of engineering. So for now, I just want to introduce it to you as if you were really looking for the square root of -25, what you do is find the square root of +25, which is 5, and then you just plot that I after it if it's a negative. Right, but the important thing to remember is this is all imaginary. All right, so back to this. All right, let's see what happens when we try to graph this thing. All right, you can see what happens. Here's the issue. Here's your x-axis. There are no x-intercepts on this particular quadratic equation, which means then there's no solution to this problem if y is equal to 0. Right? So since there's no solution if y equals 0, that means it has no x-intercepts, or what we would say is no roots. All right, so basically if that ever happens, you just know the line is either above the x-axis if it's upward facing, or it's below the x-axis if it's downward facing. It has no x-intercepts. All right, last section. Where did the quadratic formula come from? All right, so this is actually something you'll delve into again in Algebra 2, but that's really called deriving the quadratic formula. So basically, I got this from a website called Chili Math. All right, so I'll explain a little bit about this, but what mathematicians did to get the quadratic formula is they took this standard form where y is equal to 0, and then they solved for x. Right? And there are several ways to do it, but one of the most common ways is to use the steps involved in completing the square to arrive at the formula. So the whole step that Mrs. Quesnel used, where you set the c aside, you'll divide out the x, so you're going to end up with ax plus b, and then you'll complete the square by dividing this in half and squaring it, blah, blah, blah. They go through that step by step on this website. But basically, you start here, and after they go through it step by step, you end up with this, which is the formula you've just been introduced to, which as you work more in Algebra 2 will become very, very familiar to you. If you're interested in looking at that yourself, then Chili Math has this great, basically this great version where they take you through it step by step. I'm sure that several of you would be able to understand it, if not all of you. And if you're interested, just check out Chili Math. But all I expect you to know for now is they got the formula by taking the standard equation, setting y equal to 0, and solving for x. And after multiple steps that involve completing the square, they end up here at this very common formula. All right, so that's it. You've now been introduced to the quadratic formula. Again, if you mention this sometimes to adults in your life who've taken algebra, they'll remember this. This is one of those things that for some reason often sticks with people. All right, so just answer the questions on the Google Doc to show me that you really did watch the video. And we'll have just a couple more lessons that I think will be a little bit easier than this. So we're winding it down now. All right, thank you, everyone.